we're going to start by talking about the atomic nucleus. And we'll begin by talking about the size of the nucleus. So if you recall, an atom is going to have a nucleus, and then it's going to be surrounded by electrons. So then the size of an atom, so the distance from here over to here, is approximately 10 to the negative 10th meters. So that's the diameter of a typical atom. But we're interested in what is the diameter of the typical nucleus, and that is going to be 10 to the negative 14th meters. So that means that a nucleus is about 1/10,000th the size of the atom itself. So just to give you a rough idea for what does that mean, imagine the kind of football stadium that the Super Bowl is played in. They're gigantic. All right, now imagine that you take a pea and you put that on the 50-yard line of that Super Bowl stadium. So that pea would represent the size of the typical nucleus, and then the Super Bowl stadium would represent the size of the typical atom. So that means that atoms are mostly empty space. Okay, now let's look at the constituents. So the things that are inside the nucleus are going to be the protons and the neutrons. And the protons are going to have positive charge, and then the neutrons are going to be electrically neutral. Now what about their masses? So what's the mass of a proton and a neutron compared to the mass of the electron? Well, imagine a ping pong ball and then two bowling balls. So a bowling ball is roughly 2,000 times more massive than what a ping pong ball is. So that means that protons and neutrons are, roughly speaking, 2,000 times more massive than the electron. So that means that most of the mass of an atom, again, is located in that teeny tiny nucleus. So now let's go up and talk about what density means. So density is given by the letter rho, and it's equal to mass divided by volume. And we now know that the atom's nucleus is very, very small. So if you have a very small volume, then what comes out is a very large density. So you can see there's the density of the nucleus is 10 to the 17th power, and the density of ordinary water is 10 to the 3. So you can see that the density of a nucleus is much greater than the density of water. All right, let's take a break, and when we come back, we're going to discuss what an isotope is.